So we'll continue with the discussion. So we have a lot of independent modules in Unit 1. So noise part is completely over, and the linear and non-linearity part is also over. Now we are going to focus on MOS. So the basics of MOS device physics we are going to see. So MOS belongs to, you should be knowing this basics. It belongs to field effect transistors where the voltage is going to control the current in your FET, whereas in BJTs you say it's the current control device where your base current is going to control your collector current. So it was first patented in 1925, but there was no technology to fabricate FET. But then Shockley tried to create a field effect transistor where he told that he can change the conductivity of semiconductor by applying a voltage. Many people were successful in fabricating FET, and soon FET started overcoming BJT in all applications because the main property what FETs have is they don't have the property of thermal runaway. So temperature dependence in MOSFET is very, very minimal, and also the input impedance projected by MOSFET is infinity ideally. So the gate side is completely insulated, so it provides an infinite input impedance, which is the most requirement for an amplifier because the amplifier should have a maximum input impedance and it should not drain your source. So these two properties of MOSFET made it very popular candidate once it was started fabricated, and it started slowly replace BJTs in the market. Silicon, germanium. Now we have so many other elements from which MOSFETs are fabricated, and they have excellent properties also. So these are the different people who fabricated the MOSFET. Shockley, and Shockley was the one who persistently tried with the manufacturing, and he invented the BJT as well as he invented the MOSFET, which is also a family of transistors.